Okay, example 2, 2-point charge, -3 here and -5 are placed 12 centimeter and 30 centimeter from point P here. So determine the magnitude and direction of the electric field intensity at point P. Okay, so for electric field, one thing you should remember is the direction for electric field for a positive charge will be away from the charge. Okay, so the electric field for a positive charge is away from the charge, and then electric field for a negative charge is towards the charge. Okay, so if you were to draw, you should follow this here. Okay, so let us try to draw based on what I've just explained just now. So the point at point P here, both of these are negative charge, so the electric field will be pointing towards the charge lah. Okay, so this will be pointing towards the charge, and then this will be pointing towards the charge as well. Boleh kan? So this is gonna be E2, and then this is gonna be E1. Why? Because this will be pointing towards the charge. This is pointing towards the charge, so we label it as which charge are you pointing to. Begitulah. Okay? So the magnitude and direction of the electric field intensity, we can use the formula E. I'm just gonna use red. Just gonna reduce this. Okay? So I'm gonna write E1 equal to KQ1 R1 square. Okay, so this is R1, this is R2 lah. Okay, so for electric field due to charge 1, it will be equal to 1.88 times 10 to the power of 6. Okay, so the direction is to the left, as can be seen in the diagram. And then for electric field due to charge 2, it will be equal to 5 times 10 to the power of 5 Newton. Sorry, I forgot to write the unit, per coulomb. Okay? Right, so since this is a vector, in order for you to add them both together, you have to add them as vectors lah. Okay, so the electric field at point P is electric field at 1 due to 1 and due to charge 2 lah. Okay, so add this together. E1 is to the left, so it is negative 1.88 times 10 to the power of 6 plus dengan 5 times 10 to the power of 5. It is positive because it is pointing to the right, so you should get negative 1.38 times 10 to the power of 6 Newton per coulomb. Okay, alright. And then question B, the net electric force exerted on charge plus 1 microcoulomb if it is placed at point P. So this is basically applying this formula lah. Okay, so the value of F is just the product of these two, then you should get the value of 1.38 Newton. Okay, oh, don't forget to write the direction. This is to the left because it is negative. Okay, and then question C, the distance of a point from Q1 from charge 1 where the electric field is 0. Okay, so there is a point where the electric field is 0, and we have to find that point, and that point is from Q1. Okay, from charge 1, so we can label that as X lah. Okay, so this is charge 1, and then there is a point. I'll label it as point A. Okay, and then based on the question just now, this should be equal to 12 plus 30. I'm just gonna write R1 too lah. Okay, so this one here is gonna be what? R12 minus X lah kan? Okay, so we are looking for that value of X, which is the distance. Okay, since they cakap a point where the electric field is 0, then we can say that E1 is equal to E2 lah. Okay, so this is gonna be KQ1 over X square equal to KQ2 over R12 minus X square there. Okay, so rearrange that. You should then get x to be equal to 0.183 meter. Okay, alright, so that is the solution for example number 2.